Pluto, once hailed as the ninth planet of our solar system, has always fascinated astronomers and the public alike. Discovered in 1930, this icy world was, for decades, considered the outermost boundary of our planetary family, a lonely, mysterious outpost at the edge of the Sun's influence. Even after being reclassified as a dwarf planet in 2006 by the International Astronomical Union, Pluto has refused to fade quietly into the cosmic background. Instead, it continues to spark debate and curiosity, especially with its unusual orbit and complex surface features revealed by the New Horizons mission. Now, recent statements by renowned astrophysicists Neil deGrasse Tyson and Michio Kaku have once again cast a spotlight on this distant world. They've introduced a striking and controversial idea: what if Pluto, in its strange, tilted orbit, is slowly edging toward a catastrophic encounter with Neptune? Could these two celestial bodies be on a path that might one day lead to collision, chaos, or even cosmic transformation? While the idea sounds like the stuff of science fiction, it opens up profound questions about orbital mechanics, planetary stability, and the unseen forces at play in the outer solar system. This idea may sound alarming, but it's rooted in Pluto's highly eccentric orbit. Unlike the nearly circular paths of the major planets, Pluto follows a steep, oval-shaped orbit with a 17 degrees tilt relative to the ecliptic plane. Remarkably, for about 20 years during its 248-year orbit, Pluto comes closer to the Sun than Neptune. This curious crossover raises a question: why haven't these two bodies ever collided? The answer lies in the elegant balance of celestial mechanics. Although Pluto's orbit intersects Neptune's, gravitational interactions, especially a 3-to-2 orbital resonance, keep the two safely apart. For every 3 orbits Neptune makes, Pluto completes 2. This resonance ensures they never get too close, even though their orbits cross. After Pluto's discovery in 1930, astronomers quickly noted its peculiar orbital behavior. Its chaotic motion, influenced by the gravity of Neptune, Jupiter, and other outer planets, still manages to remain stable over vast timescales. Simulations show that while small variations in Pluto's orbit can lead to turbulence, it likely remains on a predictable path for billions of years thanks to the stabilizing pull of larger planets like Jupiter. As scientists delve deeper into the cosmos, the ramifications of these theoretical collisions shed light on the delicate balance that governs planetary movements. Indeed, the thought of a Pluto-Neptune clash paints a vivid picture of chaos amidst the serenity of space. Experts argue that even drawing attention to these possibilities encourages a more comprehensive exploration of celestial mechanics, contributing to our overall grasp of how planets interact over eons. With each new model and simulation, we inch closer to demystifying the extraordinary dance of these distant worlds and their unpredictable fates. Warnings from Tyson and Kaku. In understanding the universe's complexities, it becomes clear that constant vigilance and research are essential for anticipating the unforeseen. By acknowledging these threats, we not only prepare for the unknown but also inspire future generations to seek knowledge about the cosmos around us. Michio Kaku suggests that such high-energy events could even provide insights into fundamental physics, possibly offering real-world environments to test theories like string theory, where extreme gravitational conditions could reveal deeper truths about the nature of matter and forces. Moreover, Pluto remains a key to understanding the outer solar system. NASA's New Horizons mission, which flew by Pluto in 2015, delivered stunning images and data, revealing icy mountains, nitrogen plains, and complex geological activity. These findings not only deepened our knowledge of Pluto, but also raised new questions about how such distant bodies form and evolve. Pluto's orbit also sheds light on the Kuiper Belt, a vast region beyond Neptune filled with icy objects. Studying its motion helps scientists learn about planet migration, and the gravitational interplay that shaped the early solar system. In conclusion, while the prospect of a Pluto-Neptune collision makes for a dramatic headline, it remains speculative. Yet the very idea encourages us to explore the delicate balance of forces that shape our cosmic neighborhood. As Tyson and Kaku suggest, the mysteries of Pluto's path might one day unlock new chapters in our understanding of space, physics, and the universe itself.